Hello and welcome to Applied Mathematics for Business, CQMS 110. I am Dr. Pauline Fu. In this video, we'll talk about linear functions / equations 1. Topic includes notion of function and relation, linear function, slope of a line, equation of a line, parallel and perpendicular lines, solving equation with one variable, graphing linear functions. First, we introduce rectangular coordinate system, also called Cartesian coordinate system. In this system, you have the x-axis and you have y-axis. You have origin. And x-axis, y-axis divide the plane into 4 quadrants. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. Okay. For example, a point P is in quadrant 1, and s coordinate equal to x equal to 4, y equal to 5. And the point Q in quadrant 2, x equal to -2. Okay, negative 2 is here, y equal to 3, 3 is here. Okay. So the definition of a function. A function is a relationship between two variables, such that for every input value of the first variable, there is one and only one corresponding output value of the second. The function notation, we use fx. And it mentions two variables. One variable we say x, the other variable is y, and those two variables formed a pair on the rectangular coordinate system. Okay. And the notation of the function we say y equal to fx. And the domain of x and the range of the function referred to. So let's talk about the domain first. Domain is what kind of value x can are permitted. That is the domain. For example, if you have a function y equal to 2x plus 1, this is a function. The domain is x could be any number from negative infinity to positive infinity. And this is the domain of the x. Okay. And the range for this function is also from negative infinity to positive infinity. Okay. This one is actually the same as the real number r. Okay. Another example would be y equal to 1 over x. So the domain of this function means what kind of x is permitted. X can be any real number. Okay, this one means belong to. Okay, but x cannot be 0 because we know x cannot be in the denominator position. Okay, and when you have x equal to any number but 0, y can be any number. So the range is actually all the real number. Okay. So we talked about the function. So the relation is any ordered pairs are the relation. So the relation is a big concept. If this represents relation, And function is a part of this relation. This is the function. This is the relation. So function is just a special kind of relation. It is special because for every x, different x, you must get a different y. If for different x, you get the same y, that is not a function. So for example, this is rectangular coordinates, x-axis, y-axis. And if you have a graph like this, okay, something like this, for every x, for example, x equal to this number, you have two different y. One y is here, and the other y is here. You get two y. Y1 is here, and y2 is here. That violates the definition of function. The definition said, for each x, you get unique y. But here, for one x, you get two y. So this is not a function. This method we call vertical line test. You draw a vertical line, you have two intersection points, that is not function. So again, there is exact one value of the second component. Okay. So those are the example of relations. Any ordered pair in this relation, you have three ordered pair, and here you have four ordered pair for M. Okay. And if you have different x, you get different y. And let's look at the next one. This is a relation because any ordered pair form a relation. However, this is not a function because when x equal to 6, in this pair, you say y get 2. However, when x equal to 6, this pair said y equal to 5. Okay, so this violates the definition of function. Only L is function, M is function, N is not function. However, all three of them are relations. And we talk about the vertical line test. Okay, so if you have a graph like this, you draw a vertical line. If you have two intersection points, that is not a function. So now talk about a linear function. A linear function has format y equal to ax plus b, or fx equal to ax plus b. And we call this a is the slope, okay? And b is the y-intercept. The meaning of the slope is that it is a rise over run. When you have a rise over run is the slope. Okay. So for example, if you have an equation, linear equation, okay? If you have a linear equation y equal to ax plus b, ax plus b, okay? Rise for every unit, for 1 unit of change, if this is 1 unit of x, and this part is your slope. This is rise over run. Rise is vertical here, run is here. Okay, when x equal to 1 unit, the changes for y, that is the slope, a. Okay, and the intercept b is this line intersect with y, so this point from here to here, that is b. A special format of linear function is a constant function. fx equal to b or y equal to b. When you have y equal to b, no matter what x you get, y always equal to b. So the line should be here. Y always equal to b if this is b. So this graph represents y equal to b. It is a horizontal line parallel to x. If b is positive, this is the picture. If b is the negative, you get the vertical line here, y equal to b. If b is negative, b smaller than 0. Okay, this is orange. The straight line, we talk about the straight line. This is the straight line, and this is also a straight line. There are two generally used formats for the straight line. One is a point slope format. If you know a point x1, y1, and you know the slope m, this is the function. Okay. For example, if you know a point 2, 3, and you know this is a point, so x1 equal to 2, y1 equal to 3. This is a point. You also know the slope, m, for example, equal to 4. The equation is y minus y1, y1 is 3, equal to m slope multiplied by x minus x1, x1 is 2. So this is an equation, point slope form. The general form is ax plus b plus ax plus by plus c equal to 0. Okay. So if this is a point slope form, how can you change the point slope form to a general form? You just do a little bit algebra. Okay, you copy down the left-hand side. For right-hand side is equal to mx minus 2m. Okay, and then you move all these two items to the right-hand side. So left-hand side, you get 0. When you move an item across the equation, you change the sign. So become negative y plus 3. Original right-hand side, you have mx minus 2x minus 2m. Okay, minus 2m. And now you take, this is mx, so mx, this is y minus y, this is constant term 3 and minus 2m, you combine them together, plus 3 minus 2m, and this equal to 0. This is the general form of linear equation. A equal to m, b equal to -1, c equal to 3 minus 2m. Okay. So next one is the parallel and perpendicular lines. Okay. So if you have an x, y coordinates, parallel means two lines have the same slope. So these are the two parallel lines. The slope is the same. Okay. Perpendicular means the two lines perpendicular to each other. For example, you have one line here, another line here. This one is 90 degrees, so these two lines is perpendicular. When you have a parallel line, the slope are equal. The slope of first line m1 equal to the slope of the second line. Okay. When you have perpendicular lines, it is m1 equal to -1 over m2. or m1 multiplied by m2 equal to -1. Okay. Solving equations. So let's clarify some terminology first. Identity equation. If you have x plus 2 equal to 2 plus x, this is an equation, but it is an identity equation. It is the same. Left-hand side equal to right-hand side, the same item. Contradiction equation. If you have x plus 2 equal to x plus 3, this is the equation, but it is contradict to itself, because when you cancel out x from both sides, you get 2 equal to 3. It is impossible. Conditional equation. So if you have x plus 2 equal to 4, this equation is true only when x equal to 4. Oh, sorry, only when x equal to 2, because 2 plus 2 equal to 4. Okay. This is conditional equation. This item, solving equation with one variable. Okay, so for example, you have 2x plus 1 equal to 3. How do you solve for x? You just do a little bit algebra, move 1 to the right-hand side. You change the sign of 1 and continue. Okay, you have 2x equal to 2. Divide both sides by 2, you have x equal to 1. The graph of function. You can use, if you graph the function by hand, for example, y equal to 2x plus 1, just for example. Okay, what you do, you construct a table. List the possible value for x, for example, x equal to 0, x equal to 1, x equal to 2. Okay, when x equal to 0, y equal to 1. When x equal to 1, y equal to 3. When x equal to 2, y equal to 5. And then you plug in those points in rectangular coordinates. Okay, so you construct a rectangular coordinates. Okay, so suppose this is 1, 2, 3, 4, 5. Okay, when x equal to 0, y equal to 1, a point is here. When x equal to 1, y equal to 3, 3 may be here. This is 1, 2, 3. 3 is here. When x equal to 2, okay, y equal to 5, 4, 5 may be here. Okay, and then you draw a line. Oops, you draw a line. This line is y equal to 2x plus 1. Okay, so this is drawing by hand. You can also join by using Excel. Okay, you can open up an Excel file. File, open new. Just increase the font size. So what you are going to do, you want to plug in y equal to 2x plus 1. Okay, so you suppose you give some x. Okay, so for example, x equal to 0, 1, 2. Oops. And then when x equal to 0, what is y? Y equal to 2 multiplied by 0 plus 1. And then you use fill handle, copy down the formula. You get those are the y value. Okay. And then, sorry, my dog is barking. And then this one, I will just call it is, maybe just say it is y. Okay. Now you highlight this xy, insert graph, scatter plot. Okay, and you get this scatter plot between x and y. Okay. Okay. And then you quick add chart element, trend line, linear, and you get this straight line. And next, how do you get equation? So you double click this straight line. On the right hand side, you check out display equation on chart. See, you have this y equal to 2x plus 1. I'll try to increase. Okay, see, 2x plus 1. Okay. So this is how do you use Excel to draw a straight line and write down the equation. Okay. So in summary, what we learned in this lecture, we have the notation of function y equal to fx. Function is just a special situation of relation. Any paired points are the relation. The linear relation, linear function, y equal to ax plus b. A is slope, b is intercept. Okay, slope. And equation of the line I just showed you in Excel and by hand. And parallel perpendicular line, parallel means two lines, slope are the same, perpendicular. They have 90 degrees of those two lines. Okay. When you have parallel line, the slope is equal, m1 equal to m2. When you have a perpendicular, those two numbers multiplied together equal to -1, the slope of the two lines. Solving equation with one variable, something like 2x plus 5 equal to 9. Okay, easy job. Okay, so 2x equal to 4, x equal to 2. Okay. This is a solving equation. Graphing linear equations. You can do the graph by hand using x, y coordinates. And set up some value for x, figure out what is y, and plug in the point. The other way you use the Excel. Okay. That's all for this lecture. Thank you for watching.